This example is partner practice number 5. Looks like we skipped a few. There's 1 and 2, and then just skipped over to 5. But anyway, we're going to take a look at, looks like this laundry list are all limit questions. So let's investigate A, B, and C here. And this is the limit as x approaches -6 from the left, the right, and the two-sided limit. So let's count off here. 1, 2, 3, 4, 5, 6. So I think -6 is going to be right here. And let's investigate the limit from the left. The limit from the left is actually going to be -1. And the limit from the right, as x approaches -6, that is going to be +4. It's the y value that we're approaching or getting close to. Because those two values are different, we're going to say that the two-sided limit does not exist. If the two values for the limit from the left and the limit from the right around that x value exist and are the same, then we would say that the two-sided limit exists. Let's keep going here. We're going to work with D and E. So that's as x approaches -3 from the right, and then the two-sided limit. So -3 is right here, and the limit as x approaches -3 from the right is -3. That's the y value that we're approaching there. What about the two-sided limit? Well, as we approach -3 from the left, we're actually approaching that same y value. And that same y value is -3. So we're able to list that as our answer. The next three, F, G, and H, deal with -1. So let's bounce back up to the graph here. And we're going to take a look at -1 now, or as x approaches -1. So from the left, we're approaching a y value of 2. That's right here. From the right, we're approaching a y value of 2, which means the two-sided limit exists and is also 2. So we can say the limit as x approaches -1 from the left, that's what the little negative sign means right there. That happens to be 2. The limit as x approaches -1 from the right, that's the little plus sign, that's 2. And because the limit from the left is the same as the limit from the right, the two-sided limit will be also the same. Let's take a look at x approaches 1 now. That's letter I, or part I. So we're going to go here to 1, and it looks like this function is actually continuous here at 1. So the limit from the left and the right are the same. And that means that that two-sided limit will be the same value for y, which happens to be -1. And now we're going to investigate 3. So if we investigate 3 here, that's J, K, and L. We're going to take a look here, see what the limit as x approaches 3 from the left side is. So that's going to be -infinity. The limit from the right is +infinity. So we can list that here. -infinity, or you can say does not exist. And this one's infinity, or you can say does not exist. That was from the right side only. And the only thing we can say here for the limit as x approaches 3 is does not exist, because the limit from the left is not the same as the limit from the right. And we'll try a different color here as well. Maybe we'll switch to green. Hopefully you can see the yellow. And now we're investigating the limit as x approaches 8 from the right. That's part M. And then the limit as x approaches 8 from both sides. That's part N. So let's go to 8 here, and we'll try to figure out where that is. I think 8 is going to be about right here. So the limit from the right is -infinity. Looks like there's a vertical asymptote right here. The limit from the left side is also -infinity. So there's a few different choices here. For this one, we can say -infinity or does not exist. And actually, the limit from the left is the same as the limit from the right. So we can describe this two-sided limit as -infinity, or once again, -infinity is not a number. So you can say that that function does not have a limit there when x approaches 8.